Every day, more than 180,000 vehicles cross a single bridge connecting Brooklyn and Staten Island. If you've ever driven across it, chances are you didn't spend much time thinking about what's holding it up. Traffic moves. The skyline stretches out in the distance. Ships slide quietly beneath the span. But hidden inside this enormous structure is a problem most drivers never see. After more than 60 years of salt air, heavy traffic, and constant vibration, parts of the bridge are slowly deteriorating from the inside. And engineers are now racing to protect one of the most important crossings in the American transportation network.
Car that's on fire on the Verrazzano Bridge.
Drivers who use the Verrazzano Bridge may have to pay in both directions.
Verrazzano Narrows Bridge.
Verrazzano Bridge.
This is the Verrazzano Narrows Bridge. And keeping it healthy has become one of New York's most important infrastructure challenges. When the Verrazzano Narrows Bridge opened in 1964, it instantly became a symbol of American engineering ambition. At the time, it was the longest suspension bridge in the world, surpassing San Francisco's Golden Gate Bridge. That record stood until 1981, when the Humber Bridge in the United Kingdom took the title. Even today, the scale of the Verrazzano is difficult to grasp. Its two towers rise 693 feet above the water, and the central span stretches 4,260 feet across the Narrows, the narrow entrance to New York Harbor. The distance between those towers is so great that engineers had to account for something most bridge projects never worry about: the curvature of the Earth. Because the planet curves slightly across that distance, the tops of the towers are actually farther apart than their bases, ensuring the suspension cables align properly across the span. It's a subtle detail, but it hints at the extraordinary scale of the project. The Verrazzano was never meant to be just a landmark. It was designed as the southern gateway to New York City, linking Staten Island to Brooklyn and the region's wider highway network. Today, more than 180,000 vehicles cross the bridge every day, making it one of the busiest crossings in the United States. And just beneath that roadway lies another critical gateway. The bridge stands above the entrance to the Port of New York and New Jersey, one of the largest shipping hubs in North America. Massive container ships pass beneath the span as they enter the harbor. So the Verrazzano doesn't just move commuters. It sits directly above one of the most important maritime gateways on the East Coast. Like many major infrastructure projects of the mid-20th century, the Verrazzano was designed for a very different transportation world. In the 1960s, traffic volumes were significantly lower, and the heavy Class 8 freight trucks that dominate modern supply chains were far less common on American highways. Today, the bridge carries far more traffic and far heavier vehicles than its original designers anticipated. Every vehicle crossing the bridge creates small forces within the structure. One car isn't a problem, but when those forces are repeated hundreds of thousands of times every day, the stress adds up. And then there's the environment. The Verrazzano sits directly above saltwater. Ocean winds carry microscopic salt particles that settle on the steel structure. Over decades, that salty environment slowly contributes to corrosion. Which brings us to the part of the bridge that matters most: the suspension cables. The Verrazzano Narrows Bridge is supported by 4 enormous suspension cables. Each cable contains exactly 26,108 individual steel wires, bundled together into a massive structural rope. Altogether, the bridge contains more than 100,000 miles of steel wire inside those cables. That's enough wire to wrap around the Earth several times. But here's the challenge. Even tiny amounts of moisture can seep into the microscopic gaps between those wires. Once moisture enters the bundle, corrosion can slowly begin. And because the cables are sealed structures, that damage can occur deep inside, far beyond what inspectors can easily see. So the biggest threat to this massive bridge isn't visible from the roadway. It's hidden inside the cables holding the entire structure up. If enough wires were to weaken over time, the overall strength of the cable could gradually decline. Not something any engineer wants to discover too late. To prevent that scenario, The Metropolitan Transportation Authority launched a $249 million cable preservation program. The solution is surprisingly sophisticated. Engineers are installing a dehumidification system inside the suspension cables. The cables are wrapped in protective membranes, and dry air is circulated through the interior of the bundles. By reducing humidity inside the cables, the system removes moisture and dramatically slows corrosion. At the same time, engineers are installing acoustic monitoring systems along the cables. These sensors listen for the acoustic signatures of potential wire breaks or other stress events deep within the cable. If something begins to fail inside the structure, engineers will know almost immediately. As of early 2026, installation of the preservation system is underway and expected to continue through 2029. While engineers work to protect the bridge itself, another improvement project is underway at the Brooklyn end of the crossing. For decades, the ramps connecting the Verrazzano Bridge to the Belt Parkway created a major source of congestion. The original design included left-side exits, forcing drivers to merge across multiple lanes of high-speed traffic. Anyone who has driven through a busy highway interchange can imagine how well that works during rush hour. Heavy trucks, commuters, and unfamiliar drivers all trying to cross lanes at once. The result was frequent delays and safety concerns. In August 2025, the Metropolitan Transportation Authority awarded a contract to reconstruct the Brooklyn interchange. The project will relocate those ramps from the left side of the roadway to the right side, improving both safety and traffic flow. The redesign will also include wider shoulders, improved pedestrian access, and new noise barriers to reduce traffic impacts on nearby neighborhoods. And just to make the project more complicated, all of this work must happen while more than 180,000 vehicles continue using the bridge every day. Maintaining the Verrazzano Narrows Bridge is a permanent operation. The structure is so large that it requires teams of engineers, inspectors, and maintenance crews working year-round. Steel sections are constantly repainted to protect them from corrosion. Wind forces sweeping through the Narrows are continuously monitored, and thousands of structural components, from bolts to bearings, must be inspected on a regular schedule. In other words, the Verrazzano isn't just a bridge. It's a massive mechanical system stretched across New York Harbor, and keeping it healthy requires constant attention. More than 60 years after it first opened, the Verrazzano Narrows Bridge remains one of the most important transportation links in the United States. More than 180,000 vehicles rely on it every day, moving people and freight across the entrance to New York Harbor. But like many of America's great infrastructure projects, it now faces the challenge of aging in a modern world. The preservation work underway today, from cable dehumidification to interchange reconstruction, is not simply routine maintenance. It is an investment in keeping one of New York City's most important gateways open for decades to come. Because if the Verrazzano were ever forced to close, the consequences would extend far beyond the skyline of New York. From daily commuters to international shipping routes, the bridge plays a quiet but critical role in the movement of people and goods across the region. And protecting it has become one of the most important infrastructure challenges facing New York today.